Hi. So this is the fourth video of our combinatorics course. We'll talk about permutations in today's video. So let's start the topic by getting into a question. So the question is, 8 people participate in a race. 8 people participate in a race. Now, the question is very simple. In how many ways can the competition end? In how many ways can the competition end? So basically what we mean is each ending of a competition is one particular order in which the participants ended up on the finish line, right? So suppose the participants are A, B, C, D, E, H, E, F, G, H, then A could have been first and C could have been second, or D could have been third, and so on. All 8 participants would get their own position. That is one way the competition can end. And obviously, there are many other ways in which the competition could end also, with different participants getting different positions, right? So this is my question. So how do we think about it, right? So I will start off with a sub question. So the question that I will ask is, how many possibilities are there for a winner, right? How many possibilities are there for a winner in this situation? So clearly there are 8 participants. So there can be 8 possibilities for winners, right? Then next, how many possibilities for a runners up? How many possibilities for not just a runners up actually, for the ordered pair, of winners and runners up? Winner, comma, runner up. This is clearly an ordered pair. Why is it ordered? The reason it is ordered is because it matters who the winner is and who the runner up is. And if you change the order, say A comma B is not the same as B comma A, that is a totally different result of the race, right? If B wins and A is the runner up. So how many possibilities are there for the runner up? So this, by the multiplication principle, we know winner had 8 ways and this had 7 ways because there are 7 left, right? Multiplication principle says that this ordered tuple or ordered pair basically can be created in 8 into 7 or 56 ways. So just generalizing that idea, if I have to create one particular one ending of the race, that will be how many ways can I create this tuple, right? First place, second place, third place, and 8th place, right? This is an 8 tuple that you have to create. And by generalized product principle, you know that this can be done in 8 into 7 into 6 into 5 into so on 2 into 1, right? That is equal to 5040 or 8 factorial ways, right? So this race can be decided in 8 factorial different ways, right? So that suggests something that says that this theorem is likely. So what is it? For any positive integer n, for any positive integer n, the number of ways to arrange all L elements, to arrange all n elements of the set 1, 2, 3 till n is equal to n factorial. And arrange all the elements of a set in a line here. Because if you arrange them in a line, that is the same as saying how many different ways can you end the tournament, right? In our case, for the tournament example, we had n is equal to 8, and each different arrangement on a line, let's say A was first or C was second and D was third and B was fourth and so on, right? Each different arrangement on a line was one particular ending. We saw that it was the generalized 8 tuples number of ways in which you can form that, and that is simply 8 factorial in that case, right? Now N factorial is an interesting number. N factorial grows very fast, grows very fast. On a side note, you can say that no matter n factorial is always greater than a power n as long as a is a fixed positive real number. Positive real number. Like basically what I'm saying is you can always pick an n large enough such that n factorial will be greater than a power n. You can always pick an n. You can pick an n large enough such that n factorial is greater than a power n. So that is very interesting. You also have something called Stirling's formula or Stirling approximation for n factorial. There is a nice video on that that I had made earlier. I mean, the application of that formula. But you should know that this is almost equal to root 2 pi n power n plus half e power minus n. So basically, as limit n tends to infinity, this and this will be equal to 1, right? Both of them will be the same thing as n tends to infinity. But these are asides. We already know, we have focused on the combinatorial part of it, and we know that number of ways to arrange the set of 1 to n in a line is n factorial, right? So this concept is very important in combinatorics. So we give this concept a special name. It is called a permutation. A permutation is an arrangement basically. And I will say that a permutation of a finite set S, a permutation of a finite set S is a list of elements of S, is a list of elements of S containing each element exactly once, containing each element exactly once, exactly once. So this is the meaning. So basically you rearrange the elements of S, and we also have the number of permutations, the number of permutations of the set 1 to n, of the set 1 to till n is n factorial. Okay, so let's do another theorem here. Theorem is, suppose you have to not select all of the elements of 1 to n and you have to select only a few elements, right? Then how many permutations will be there? So let n and k be positive integers such that n is greater than equal to k, n is greater than equal to k, then the number of ways to make a k element list, make a k element list from the set 1 to n. So basically what I said earlier, like instead of arranging all n elements, if you have to arrange only k elements out of this 1 to n, right? Then how many ways can we do it without repeating any elements? Without repeating any elements. Any elements. This will be, so basically we have to select a k tuple, right? We have to create a k tuple, and these are number of ways to arrange that k tuple. So the first spot in the k tuple will be arranged in n ways, because you could have any choice of all of the n letters for the first spot. And second spot will be n minus 1, third spot will be n minus 2, and similarly kth spot will be n minus k plus 1, right? So this product is coming by the generalized product principle, and because we have only k spots, these are k, which we have out of which we have to fill out of n different things, right? So that logic suggests that this product will be the answer, and this can sometimes be written as npk, or sometimes even with the symbol nk. And if you notice, this is equal to n factorial by n minus k factorial. So you should check that for yourself, that n factorial by n minus k factorial will be this, right? So this is very important, sometimes also called npk. This is the number of ways to arrange k elements out of a set of n elements, given that you do not repeat any elements, right? Okay, so let's end with a simple example where we utilize this idea and should give you some sort of a sense of how to go about questions like this. Obviously, I'll link in the description to more detailed videos and more details on permutations. There are several videos on my channel which have this in much more detail. And we will see as we go further, we'll see many more examples as well. So there is nothing to worry. The question is this: a student will spend the weekend looking at schools, will spend a weekend looking at her favorite schools. Looking at schools. Now, she can either go north, she can either go north and visit 4 schools out of 10 schools, 4 schools out of 10 schools that she likes, out of 10 schools, or go south and visit 5 out of 8 schools that she likes. 5 schools out of 8 schools. 8 schools. So how many ways can she make her itinerary? Many ways can she make her? So basically, an itinerary is basically a plan of when to go where and what is the next stop from somewhere, right? So if I want to go to 3 places, this is one itinerary. And if I change the order, this is a different itinerary, right? So order definitely matters here. Order matters. Even if you go to the same schools, but you change the order, that's a different thing, right? So this question is a simple application of the concept that we have learned. Right now, notice first that she has 2 choices. She can either go north, or is here, and or is super important here, or she can go south, right? So north is one choice, and then there is south, which is another choice. So there is an or statement in between, and we saw earlier that or statement means it's a union of these 2 cases. So by addition principle, we will have to add the number of elements in this set and add the number of elements in this set, right? So how many ways can she plan an itinerary for the north, right? She has to visit 4 schools out of 10 schools. So the set of n, the n set is basically school 1, school 2 till school 10. But she can go to only 4. So you have to select a k element subset. And this is the previous theorem being applied here. So this can be written as 10p4, right? Or 10 4, or 10 factorial by 10 minus 4 factorial, is 6 factorial, right? So that becomes simply 10 into 9 into 8 into 7. Plus, similarly, for the south, she has to do 8p5, right? So that is 8 by 3 factorial. So that is equal to actually 8 into 7 into 6 into 5 into 4, right? And that becomes, the value of this is 6,720 and the value of this is 5,040. And eventually now you'll add up and you'll get basically 11,760 different itineraries can be planned here. So I hope you are understanding what is going on here. You're first done the or, which is A union B. So you have two possibilities and you have to add the number of elements in each of those sets, right? And for the not set, you are selecting 4 schools out of 10 possible schools. And order definitely matters here. If you go to school A, B, C, D, you can also go in a different order, B, C, D, A. That's a different itinerary, right? And similarly, 8P5 for the south, right? So that is a simple application that should reinforce what we have just learned in this video. I will send a link in the description for more detailed videos on permutations. And I hope you learned something from this session. I'll see you next time. We'll have more videos coming up in the combinatorics series. Stay tuned and keep learning.